Good evening. So Chandrayaan 3 was launched. For this week current affairs, I am going to cover about the moon. Okay, so that means I am going to cover Chandrayaan 1 mission, 2, what happened to Chandrayaan 2, and then we will go to Chandrayaan 3 mission. What are the different kinds of moon missions and why do we need to explore the moon? Okay, and particularly very important, ISRO is aiming for the south pole. Okay, ISRO is aiming for the south pole of the moon. Okay, it is aiming to lander at the south pole of the moon. What is the importance of the polar regions of the moon? So these are some important topics, okay, for this week. So as a whole we are going to study about the moon. Okay, about the moon. So but before starting the class, please write down 3 objective questions, and one of them is very easy. I know you can answer that question as well. So please write down 3 objective questions. First question: which space agency launched humans onto the surface of the moon? Options ivvala diniki. European Space Agency, let me give China. What is the answer for this? Yes. Okay. Write down the questions. Okay. Of course, the answer is NASA only. It's a very simple question. Okay. Only NASA had been able to launch humans onto the surface of the moon till now. Okay. Next question. One lunar day. Next question. One lunar day is equal to one lunar night is equal to what? Okay, the options are, okay, 12 earth days, okay, 13 earth days, 14 earth days, and 15 earth days. Okay, so one lunar day is equal to one lunar night is equal to what? Okay, so you can write note: one earth day is equal to, okay, 24 hours. That means day of the earth plus night of the earth, one complete day. Okay, but here that's why I have given this. So here day means day where there is a sunlight, here night means where there is no sunlight. Okay, so this is one question. We are going to answer all these questions and completed a next question. Next question. Which country launched its lander on the far side of the moon? On the far side, in bracket, okay, far side is also called as other side. Other side, on the far side or other side of the moon. Which country? Okay, as I have mentioned country, so just write down the names of the countries. Okay, no problem. European Space Agency. What is the answer for this question? Okay, first we need to know what is far side of the moon, what is other side of the moon. Okay, this mission is also very important actually, we will see. So these are some important objective questions. Now we will go to the topic now. Completed. What is the answer? So what are the different types of moon missions? Okay, so the first topic here is, I am not putting any slides here because I am going to discuss several things. Okay, no need of slides here. So different types of moon missions. This class is very important okay, for mains examination, prelims examination and upcoming civil services mains examination or state public service mains examinations. Okay. So, what are the different types of moon missions? Okay, the first one, okay, in this the first one, okay, fly-by mission. Fly-by mission. So, what is a fly-by mission? See, this basically it is a spacecraft. Okay, in this spacecraft passes near to the moon. Spacecraft passes near to the moon, but do not enter into the orbit of the moon. But do not enter into the orbit of the moon. But do not enter into the orbit of the moon. That means this particular mission is not going to rotate around the moon. Okay, it will just pass by the moon and will collect some good information about the moon. Is this point clear? Yes. But see here, this type of mission can be exclusively for the moon. Okay, that means it is of two types. Okay, can be exclusively for observing the moon. Okay, for the moon, that means for observing the moon. Okay, or this flyby spacecraft, okay, is actually going to some other planetary body, or into some deep space mission. Okay, on its way it have just visited the moon and collected some good information about the moon. Is this point clear? Yes, please write down that one. Okay. So it can be exclusively for the moon, or this flyby spacecraft is going to some other planetary body or into deep space mission. Okay, on its way it collected information about the moon. Okay, yeah? On its way it collected information about the moon. So this is about flyby mission. Now, what is an example of the flyby mission? The example is Luna 3 of USSR. So this is an example of flyby mission. Okay. Second, next one. Okay. Orbiter. It is a kind of mission. Okay. In this, okay, so around the moon, so this is moon. Okay, around the moon a spacecraft orbits around the moon. Okay, a spacecraft orbits around the moon and it is an orbiter. It will collect good information about the moon. Okay, what is the example of this one? You can tell. Okay, example is Chandrayaan 1. Okay, under this mission we have launched a spacecraft which orbited around the moon. Okay, so that is about this. It's very simple. So second one is impact mission. Okay, see, under this impact mission, first there will be an orbiter and there will be an impact probe. There will be an orbiter and there will be an impact probe. So that means, suppose if this is the moon, okay, and this is the orbit of the moon. So under this mission, okay, we will launch a spacecraft, okay, to orbit around the moon. After spacecraft making some few orbits, okay, so there is something called impact probe which is present inside this orbiter, and impact probe got separated from this orbiter and makes a landing on the surface of the moon. and makes a landing on the surface of the moon. But the point important here is impact probe means it will make an uncontrolled landing. There are two types of landing, one is soft landing, one is hard landing. Soft landing is actually a controlled landing, hard landing is a uncontrolled landing. Is this point clear? Yes. So what will happen when this moon impact probe, actually moon impact probe is actually a word of Chandrayaan 1, let us call here impact probe, a general word. What happens when this impact probe made an uncontrolled landing on the surface of the moon? It is going to get smashed, crashed, it is going to be destroyed. Is this point clear? Yes. So this impact probe separates from the orbiter, please write down, separates from the orbiter and makes a uncontrolled landing on the surface of the moon, uncontrolled landing on the surface of the moon. So what will happen then? Impact probe will be destroyed, it will be smashed. That is about this impact probe. What is the example of this? Chandrayaan 1 actually. So under this Chandrayaan 1 mission, what we have launched is an orbiter with moon impact probe, Of course we are going to discuss this mission, so the details I will give there. So this is about the impact mission. Next, these are very simple things, but we need to consolidate all these concepts at one place. Next, lander. Under this lander mission, definitely there will be an orbiter and there will be a lander. Suppose if this is the moon, so we will launch a spacecraft to orbit around the moon, and this is the orbiter. And what will happen is, after few this rotations around the moon, the lander will get separated from this orbiter and will land on the moon. So lander means it will be a soft landing. It will be a controlled landing. Is this point clear? Yes. That means it will softly land on the surface of the moon and then it will do some research. It will collect information about the moon. Is this point clear, everybody? Yes. So earlier in the impact mission, this impact probe is a uncontrolled landing and this lander is a controlled landing. So that is the difference between impact mission and lander mission. So please get a clarity here. Fine. So what is the example here? Chandrayaan 3 is the example. When we are discussing Chandrayaan 3, I will tell the details about this one. Next is a rover. So next is rover. So rover means definitely there has to be an orbiter and definitely there has to be a lander and then there has to be a rover. Now, so what will happen here? Same diagram here. We will launch a spacecraft to orbit around the moon. So that is the orbiter, and then lander will get separated from the orbiter and makes a safe landing on the surface of the moon and makes a controlled landing on the surface of the moon. So from the lander, the rover will get separated. So lander is a stationary thing here. And the rover, we can say it moves. It moves and do some research on the surface of the moon. So next, next is human mission. What is the example of this one? Chandrayaan 3. Next is human mission. So human mission means taking astronauts onto the surface of the moon. So please write down that one. Taking astronauts onto the surface of the moon. taking astronauts onto the surface of the moon. The only country which achieved this feat, so far is yes, USA. Okay, USA. So that means NASA. So NASA is the only space agency which achieved this feat. So landing humans onto the surface of the moon. See, between 1969 and 72, so total 6 batches of 2 astronauts each. That means it totally launched 12 astronauts onto the surface of the moon. But after 1972, there are no more human missions onto the moon. Is this point clear? Please do remember this. After 1972, no country, even USA, did not launch any human onto the surface of the moon. Is this point clear? But the USA, that is NASA, has been planning to launch humans onto the surface of the moon in 2025 under its mission called Artemis 3 mission. So NASA is again planning to launch humans, that is astronauts, onto the surface of the moon under its mission called Artemis 3 mission in 2025. Okay, so this is about different kinds of moon missions. Okay, so the second topic that we are going to take up is what is the need to go to the moon. What is the need? Okay, why we need to explore the moon? Why we need to do research on the moon? Okay, please write down. Please write down. That means, okay, moon exploration. What is the necessity of the moon exploration? Okay, carefully listen. Okay, this may be an important question. Okay, for the upcoming examinations. There are many examinations. If you are writing any, you will get an advantage. Okay, but generally that we have to know this one, you will understand. So what is the need? Why we need to explore the moon? See, after Earth, if you want to go to the space, definitely we have to research about the first body which is near to the Earth. Yes or no? Yes. That is obviously what? Moon. Okay, so the first point here is moon is the nearest cosmic body. Obvious. Nearest cosmic body. Fine. So please write down next point. It provides a test bed. It provides a test bed to develop and demonstrate technologies needed for the deep space missions. What is the meaning of this? Okay, continuation, please write down. Needed for the deep space missions, okay, including taking humans onto the Mars. Okay. So that means if we need to take humans onto the Mars, okay, first we need to take humans onto the moon. Okay, so we will develop rockets, okay, and other technologies for taking humans onto the moon, and then we will upgrade them, okay, so that we can able to launch humans onto the Mars. Is this point clear? Yes. So when we launch humans onto the moon, we will understand what are the difficulties they are facing, okay, what are the requirements as a space agency, okay, what are the requirements they have to do. Is this point clear? So it provides a test bed. Okay, of course, that is one point. Okay, the next point here is write down. See, in the early solar system, which is approximately 4 billion years ago, okay, In the early solar system, which is approximately 4 billion years ago, that is okay, just after the formation of the solar system our solar system age is actually 4.5 billion years. Okay. So what happened is many asteroids and many comets have crashed onto the planets and their moons. So planets and their moons are the natural satellites of the planets. You understand the point? Yes. So many comets and many asteroids have crashed onto the planets and their moons. Is this point clear? Yes. So when they crashed, even they have crashed onto the earth as well, the moon, okay, different planets. When they crashed, they formed craters. What is a crater? Crater is basically a depression. Okay, they formed craters. They formed craters. Now, as I told you, the craters are also formed on the earth, but on the earth we had erosional and depositional elements like wind and water. Okay, so because of the wind and water, these craters, okay, they will get leveled, they will get smoothened. Is this point clear, everybody? Yes. But moon is such thing where almost zero atmosphere, almost zero wind. So the craters which have formed 4 billion years ago are still present on the moon intact, no change. Is this point clear? Yes. If we explore those craters, we can understand the early solar system. We can understand how the solar system has been formed. Is this point clear, everybody? Yes. So please write down this point. In the early solar system, many comets and asteroids have crashed onto the. In the early solar system, many comets and asteroids have crashed onto the planets and their moons. Onto the planets and their moons. Resulted in the formation of craters. Wind and water on earth, okay, leveled those craters, but on moon, okay, which has a negligible atmosphere, and negligible wind, the craters are still present in its almost in its original form. The craters are still present almost in its original form. Okay, still present almost in its original form. So by doing research on these craters, we can know about the early phase of the solar system. We can know about the early phase of the solar system. Early phase of the solar system. Is this point clear? Next point. There is no significant tectonic activity. On the moon, there is no significant tectonic activity on the moon. That means see, what is tectonic activity? Take the case of Earth, okay, the earthquakes, volcanoes, okay, tectonic plates colliding, they are moving apart. Okay, so because of all these, what will happen? The structure of the earth has been changing, yes or no? Yes. When there is no tectonic activity, significant tectonic activity on the moon means, so when the moon formed, it has some internal structure, and that internal structure is almost preserved. It hasn't changed much. Is this point clear? So by studying the internal structure of the moon, we can understand about the early phase of the solar system. Agreed with me? Yes. So please write down. No significant tectonic activity on the moon. Okay, so its internal structure, okay, hasn't changed much. In bracket you can write hasn't changed much. Okay, by studying about the internal structure of the moon, we can understand the early phase of the solar system, because the age of the moon is 4.4 billion years. By studying about the internal structure of the moon, we can understand about the early phase of the solar system. So how do we study about the internal structure of the moon? Okay, just a point. Earlier I have told you, during the early phase of the solar system, many comets and asteroids have crashed onto the moon. So when the comets and asteroids crashed onto the moon, craters formed. Not only that, okay, the hills and mountains are also formed on the moon. So by studying those mountainous structure, okay, we can understand about the internal structure of the moon. Is this point clear? Yes. So this is about one thing, okay. So just, okay, conclude here why we need to go to the moon. Before doing the deep space exploration, first we need to explore the moon. It can be a test bed to develop technologies needed for the further missions. Okay, to know the early phase of the solar system, to know the origin of the solar system. Is this point clear? So there are 2 points about the origin of the solar system. Its internal structure hasn't changed much because there is no significant tectonic activity, and one more thing is craters. One more thing is what? Craters. Okay, that is one important point. There is actually one more important point we can write here, but I will discuss about this point. Okay, just mention, okay, there are permanently shadowed regions. There are permanently shadowed regions. Present on the moon. Permanently shadowed regions present on the moon, which can give clues about the early phase of the solar system. Okay, but do not worry, I am going to discuss about this permanently shadowed regions. This is actually a very important point, okay, when we are discussing about the one topic, okay, in this class itself. Can you tell me some more points? Minerals, okay. Okay, minerals explore cheyochu. Extra emanna unte we can, okay, that
Water minerals.
I'll agree with the minerals. Okay, water also, space tourism. Okay, if we get hold on the moon, okay, then we can promote the space tourism. You understand the point? Yes, we can also mention those points. So this is about why we need to go to the moon. Okay, so the next thing is I'll take up Chandrayaan missions 1, 2 and 3. So I will discuss them in detail. Completed? Okay. So now I'll discuss Chandrayaan 1 mission. Okay, write down important points. Okay, so this is India's first mission. India's first mission to moon. India's first mission to moon. Not only that, it is the India's first deep space exploration mission. It is India's first deep space exploration mission. Okay, so this Chandrayaan 1 was launched in October 2008. Okay, so under this mission, okay, there are two things. One is orbiter, another one is what? Yes, moon impact probe. Moon impact probe. Okay, so these two are there. So if this is the moon, at 100 kilometers from the surface of the moon, at 100 kilometers from the surface of the moon, the orbiter is rotating around the moon, and this moon impact probe separates from this orbiter and crash landed on the surface of the moon. Okay, so this moon impact probe, what I told you, it did an uncontrolled landing. Uncontrolled landing on the surface of the moon. Now, when it did uncontrolled landing on the surface of the moon, okay, there is so much of debris that has generated. Yes or no? What is this debris? This is the debris of the moon itself. When so much of debris that has been generated, this debris, okay, is analyzed by the is analyzed by the spacecraft, that is orbiter. Analyzed by the orbiter. Now, one important point here is, so this moon impact probe, okay, it had crashed on. So I am not using the landing or landed here, because that was the word which was specifically used for soft landing purpose. So I am just using the word crashed. So crashed at almost 90 degree, 89.55 degree south latitude of the moon. Okay, it had almost, okay, that is south pole, okay, it is 89.55 degrees south latitude of the moon. Now, listen, so first of all, why they have launched it, okay, just for the purpose of the point here, what is the aim of this Chandrayaan 1 mission? This is mapping of the moon. The aim is mapping of the moon. Okay, what type of mapping here? Chemical mapping, mineralogical mapping, and photogeologic mapping. Photogeologic mapping. So the purpose of this Chandrayaan 1 mission is mapping the moon. What type of minerals can be present on the surface of the moon, chemical constituents of the moon, geologic mapping of the moon, structure of the moon. Is this point clear? So that is actually, okay, aim of this Chandrayaan 1. But what are its findings? What are its findings? What are the findings of this Chandrayaan 1? I'll write here, okay, if you are comfortable. What are the findings? Do you know Chandrayaan 1, okay, anyways, I'll take up next slide, okay. What are its findings, okay, what is the result, okay? This Chandrayaan 1 mission discovered water on the surface of the moon. It discovered water and OH also on the surface of the moon. Okay, so Chandrayaan 1 discovered water on the surface of the moon. Not only that one, it also, that means from the data collected from the orbiter, okay, we came to a conclusion that the abundance of this H2O and OH, abundance of H2O and OH increased or increases towards polar regions. So that is what discovered by the Chandrayaan 1 mission. Now, so what is the vehicle used for the launch of Chandrayaan 1 mission? So these are very, very important points, students. We need to remember this. Okay, what is the vehicle here? It is PSLV C11. It is a vehicle which is used to launch. Okay, see, one thing is, so every mission, suppose if we take parts of the mission as well, spacecraft, impact probe, okay, lander, rover, so they have certain instruments embedded on them. Okay, they have certain instruments, they contain certain instruments for doing the research about the moon. Is this point clear? So I am not giving information about the instruments, you can find the information in the ISRO website only, do not check anywhere else, but I am just giving the crux of the mission here. Okay, so this point is also very important. At 89.55 degrees south latitude, that is the south pole of the moon. Okay, now this is about Chandrayaan 1. Now what are the important points here? What? It discovered water and their abundance also increases towards the polar regions. Now next we will take up Chandrayaan 2. So this Chandrayaan 1 mission also discovered ice in the north pole of the moon. It also discovered ice in the north pole of the moon, but anyhow, discovered water, that is enough. Okay. Now Chandrayaan 2. One more important point about Chandrayaan 1, we lost contact of the orbiter in August 2009. We lost the contact of the orbiter. We lost the contact of the orbiter. Okay. Chandrayaan 2, this was launched in 2019 July. What is the launch vehicle? MK3. GSLV MK3 is the launch vehicle. Okay. What does it contain? It contains orbiter, it contains lander. The name of the lander is called Vikram. It contains rover. The name of the rover is called Pragyan. The name of the rover is called Pragyan. So, we have planned, if this is the moon, this is the orbit, and this is 100 kilometers. So, for Chandrayaan 1 also, under Chandrayaan 1 also, okay, the orbit is 100 kilometers from the surface of the moon. Okay, please mention that point as well. I think I have already told that point. Okay, anyways. So, so this is about the orbiter. Lander separates from the orbiter, and it has to soft land on the surface of the moon. Okay, actually we planned to land, okay, this lander, okay, this lander, that is Vikram, we planned to land it at 70° south latitude. Students, why I am telling these latitudes? These are very important. Okay, this is actually the challenge. We will take up one more question about this. Okay, we planned this Vikram to have a soft landing at 70° south latitude. Okay, but what happened? So, lander has to separate from this orbiter and has to make a soft landing on the surface of the moon, but it did not make soft landing, it crashed on the surface of the moon. Is this point clear? Yes. That means the lander and rover both got destroyed, but the orbiter is still rotating about the, it is still rotating around the moon. Is this point clear? So, orbiter of the Chandrayaan 2 is still rotating around the moon. Is this point clear? Yes. So, what went wrong? Okay, that is what I am going to discuss here. So, what went wrong here? Wrong with lander, that is Vikram of Chandrayaan 2 mission. Okay, what happened actually? Suppose, let us, we will understand this from exam point of view, not too much technical things will be discussed here. Okay. In fact, I take this concept from Indian Express newspaper. So, the chairman of the ISRO has mentioned 3 things that happened, okay, which leads to the crash landing of the Vikram onto the surface of the moon. So, I will discuss them now. Okay. So, first of all, so when the Vikram, that is the lander, got separated from the orbiter of the moon, okay, and separated from the orbiter and want to make the soft landing on the moon. Now, from 5 kilometers to 400 meters from the surface of the moon, this is called braking phase. Braking phase. It is actually called fine braking phase of the mission. That means, so that particular lander possesses so much of velocity here. Agreed? Yes. But in order to make the soft landing, okay, its velocity should be decreased gradually to 0 almost. Yes or no? Yes. That means from 5 kilometers to 400 meters, okay, between this, the velocity of the lander, okay, should be decreased. So, at 400 meters, the velocity of the lander should be almost 0. So, this phase is also called as retardation phase. So, in this phase, what happened here is, okay, there are, so I am discussing the first point here, what led to the failure of the lander. Okay, there are 5 engines. There are 5 engines. They provide necessary thrust. There are 5 engines. They provide necessary thrust for the retardation. for the retardation. The word retardation is used for decrease in the speed. Is this point clear? So they provide necessary thrust for the retardation of the lander. So but what actually happened here is they provided more thrust. They provided more thrust than required. Listen carefully. But so these 5 engines provided more thrust than required. So thrust means you can, yes, it can be force. Okay, it can be force. So they provide more force than required. So because of this, what happened here is, okay, therefore errors got occurred in the lander, and all these errors got accumulated and the lander become unstable. It loses the stability. It become unstable. When it become unstable, so this is the second important point here, okay, it is making very fast turns. It is making very fast turns, but the point here is when it is about to make a turn, it is making very fast turns. When it is about to make a turn, the software which was put in that lander, but the software was not designed for such fast turns. Was not designed for such fast turns. It further became unstable and the errors got accumulated. It further became unstable and the errors got accumulated. So next I am discussing the third point. So what caused the failure of this, okay, lander? Now suppose when it is very near to the, suppose if this is the lander and this is the surface of the moon, when this lander is very near to the surface of the moon, actually its velocity has to be greatly reduced. But what happened here is its velocity greatly increased. Velocity increased even though it is close to the surface. Why? See here. Velocity increase even though it is close to the surface. Velocity increase even though it is close to the surface, because if this is the position of the lander, this is the surface of the moon, but the landing site was identified here. If the landing site is identified here, okay, the velocity may get reduced, okay, but it need to travel from here to here, therefore it traveled with more velocity. Its speed increases. Is this point clear? Yes. So at the last time, at the last phase, even though the lander is very close to the surface, okay, actually its speed has to be reduced, but its speed increases because the point of landing is far away from the lander. Is this point clear? Yes. So these are the 3 reasons, okay, that led to the failure of the lander. So instead of making the soft landing, it crashed onto the surface of the moon, and both the lander and rover both got destroyed. Is this point clear? Yes. Okay, this is, there may be so much technical things involved in this, but I have summarized and concluded like this, and it was beautifully mentioned in the newspaper like this as well. Okay. So this mission is a partial success. Why it is a partial success? Orbiter. Okay, orbiter of the Chandrayaan 2 is still rotating around the moon. Is this point clear? And in fact, in Chandrayaan 3, we are making the use of orbiter of Chandrayaan 2. There is no separate orbiter in Chandrayaan 3. We will see. So this is about this. Next, completed? Okay. So next we will take up Chandrayaan 3. Okay. So when it was launched? Yeah, 14 July 2023. What is the launch vehicle? Actually it is LV-M3, okay, and M4 as well. This is the launch vehicle. Okay. So what is LVM3? Launch vehicle Mark 3. నేను ఆల్రెడీ చెప్పాను మీకు. GSLV Mark 3 has been renamed as launch vehicle Mark 3. Is this point clear? And maybe they have did some improvements. LVM4 రాకముందే LVM3 M4 అని పెట్టారు. Is this point clear? So this is the launch vehicle. మీరు 2-3 రోజుల ముందు న్యూస్ పేపర్ చదివినా సరే లాంచ్ వెహికల్ వచ్చేసి LVM3 అనే మెన్షన్ చేశారు. ఎస్, ఒక సంవత్సరం ముందు చదివింటే GSLV Mark 3 అనే మెన్షన్ చేశారు ఫర్ చంద్రయాన్ 3 మిషన్. Is this point clear? Yes. So now what does it contain? Okay, it contains propulsion module, lander module, rover module. Okay, so this is what it contains. See, the lander module has 4 payloads, rover module has 2 payloads, propulsion module has 1 payload is there. So I recommend you to just refer the ISRO website and just write down what are the payloads, what is their functioning. We are discussing the overall picture here. Okay, so this is about this. Now see here. So already నేను GSLV Mark 3 that is LVM Mark 3 రాకెట్ ఎలా ఉంటుందో చెప్పానండి మీకు. ఓకే, now so what are these two? What are these two? This is S200 booster. This is S200 booster. This is one more S200 booster. So this LVM3 has 2 S200 boosters. What is this one? That. So what is this one? It is core stage. Okay, so this core stage consists of 2 Vickers engines. Okay, so they use liquid fuel and there is a name for this core stage. It is L100. Okay, now what is this one? This is cryogenic upper stage. Okay, so CUS అంటాం దీన్ని. దీనికి ఒక నేమ్ చెప్పాను, ఏంటది? C25 is the cryogenic upper stage. This stage consists of cryogenic engine. Okay, cryogenic engine. So in this cryogenic engine we use cryogenic fuel. Okay, this S200 booster we use solid fuel. Okay na? So 2 S200 boosters and there is something called core stage. It consists of 2 Vickers engines. It uses a liquid fuel and this is cryogenic upper stage. There is a name to this cryogenic upper stage which is C25. It has cryogenic engine and it uses cryogenic fuel. I told you what is a cryogenic fuel? Liquid hydrogen at -253 degrees Celsius. Okay, in order to burn that liquid hydrogen we also carry liquid oxygen at -183 degrees Celsius and that liquid hydrogen and liquid oxygen combined we call as propulsion. Okay, fuel oxidizer ni kalipte manam propulsion ani antam. Anyways, now see, this is the sequence of events that is going to follow in the Chandrayaan 3. This already happened and the same sequence of events will be there for Gaganyaan mission as well because we are using the same rocket LVM3. Is this point clear? So what is the sequence of events? Okay, so first that S200 boosters will get ignited. ignited. గుర్తుపెట్టుకోండి నాన్న, ఇదే సీక్వెన్స్ ఉంటుంది. అంటే రాకెట్ అసలు ఎలా పైకి వెళ్తుంది అనేది ఈ సీక్వెన్స్ అనమాట. ఫస్ట్ S200 బూస్టర్స్ గాట్ ఇగ్నైటెడ్. ఓకే, సో ఆఫ్టర్ సమ్ టైమ్, ఓకే, L100, that is the core stage, will get ignited, and after that 2 S200 boosters will get separated from the rocket. Boosters separation, okay. So in fact the time gap between these two is only a few seconds. The time gap between these two is only a few seconds. Okay na? Now after this only L100 is burning. This is called L100 burning phase. L100 burning phase. Okay, after this L100 burning phase, payload fairing separation. Payload fairing separation, that means actually, okay, so here, okay, the spacecraft, okay, that is propulsion module, lander module and rover module is present here. Payload fairing separation means we can understand, okay, this covering or the dome has been separated. So after this payload fairing separation, okay, so this L100 separation occurs. That means the core stage is going to be separated. First, what are separated here? 2 boosters are separated, then this L100 will get separated here. Now, and when L100 got separated, okay, at the same time, okay, at the same time, so this C25 stage, that is cryogenic stage, ignition happens. This happens, okay, almost simultaneously. So these two happens almost simultaneously. Almost simultaneously. Okay, so after that C25 separation. After that, okay, spacecraft, okay, spacecraft separation. After that, spacecraft enters into where? Enters into Earth's orbit. I'll tell you what is the process here. So it enters into Earth's orbit. See, when spacecraft and C25 separation means both are separated only. Ante kada? C25 separate అయిపోయిందంటే స్పేస్ క్రాఫ్ట్ కూడా సెపరేట్ అయిపోయినట్టే, ఎందుకంటే మిగిలింది R&D, అవునా కదా? ఎస్. ఇప్పుడు చూడండి. So what happened? Okay, so that means if this is the earth, okay, we have launched, okay, this rocket here. So ultimately the spacecraft enters into the orbit of the earth. Clear? The spacecraft enters into the orbit of the earth. Now see here, this is the earth. Spacecraft enters into the orbit of the earth. That means the spacecraft is rotating around the earth like this. Now while it is rotating, okay, it slowly increases the size of the orbit. It slowly increases the size of the orbit. Is this point clear? Why it is slowly increasing the size of the orbit? First of all, how to increase the size of the orbit? We will do maneuvering here. We will do manipulations, okay, so that the size of the orbit is slowly increasing. That means, okay, size of orbit increasing. Now after that, okay, it will escape the gravity of the earth. So why the size of orbit is slowly increasing? Why we are maneuvering here? Why we are doing maneuvering here? Such that the spacecraft is able to escape the gravity of the earth. So at one fine time it will escape the gravity of the earth and entered into the gravity of the moon. So this path is called lunar trajectory path. Okay, now it enters into the gravity of the moon. Okay, see here, just listen. Okay, now when it enters into the gravity of the moon, what will happen? Now it will rotate around the moon, and slowly the length of the orbit will get decreases. So at one fine point of time, it will come to an orbit, okay, around the moon, which is 100 kilometers from the surface of the moon. Is this point clear? Yes. Now listen here. So first it is making, so here in this direction, okay, there is decreasing size of the orbit. So decreasing size of the orbit here. Is this point clear, everybody? Yes. So here decreasing size of the orbit. One important point here is, okay, this can be a very important question for prelims examination. Suppose Earth is rotating, revolving around the sun, okay, moon is revolving around the Earth. So there are so many celestial bodies revolving around some other body. Is this point clear? But for an object to make that revolution, that is circular motion, there should be some force called centripetal force. For an object to move in the circle, there is a force called centripetal force that act on that object, and the direction of the centripetal force is from the object towards the center of the circle. But here the Earth is revolving around the sun, the moon is revolving around the Earth. That means they are making circular motions. From where this centripetal force is coming? I told you, for making the circular motion, centripetal force is very important. From where this centripetal force is coming? Yes, there is a force between Earth and sun, there is a force between moon and Earth, okay, that is gravitational force. So that gravitational force is providing the necessary centripetal force so that they can able to revolve around the other object. Is this point clear? Yes. So that means for an object it is revolving, it is making orbit around the object, means, okay, it entered into the gravity of that object. That means if you take this case, okay, the spacecraft entered into the gravity of the moon. Here the spacecraft escaped the gravity of the Earth. Is this point clear? Yes. Right. So here decreasing the size of the orbit, and finally it is rotating around the moon in an orbit which is 100 kilometers from the surface of the moon. Now listen. So what is this one? What all it contains? It contains propulsion module, lander module and rover module. Clear. Now, so this lander module and rover module, they get separated from the propulsion module and they will get land on the moon surface, soft landing. Okay, this is what we are expecting from the Chandrayaan 3. Okay, they will get soft landing, and we are going to land this lander module, okay, at nearly 70 degree south latitude. Remember, students, okay, this is something like 69 point something else, but approximately it is equal to 70 degrees south latitude. Now in Chandrayaan 1 mission, moon impact probe, it has crash landed on almost south pole. Chandrayaan 2, yes, it has landed at nearly 70 degrees south latitude. Okay, this is 70 degree south latitude. So we are aiming for the polar region of the moon. There are many missions which happened before Chandrayaan 2 and 3 which aimed at the equatorial region of the moon. The farthest they can go is 40 degree latitude. But we are aiming here. There is a reason for that. This can be a potential question in the examination as well. Fine. Now come here. So lander module will be landing on the surface of the moon. Rover gets separated from the lander. Rover will rove on the surface of the moon, and obviously they will collect some good information. There are 4 payloads present in the lander. There are 2 payloads present in the rover, and there is 1 payload in the propulsion module. Okay, just collect some good information about these payloads. You will understand their working. Okay, now here, so this rover module, listen carefully, this rover module communicates only with lander module. Okay na? As I have told you, this lander will land on the surface of the moon and rover got separated. Now they will collect information. Okay, they will collect information. Now when they collected information, after they collected information, this rover module will communicate only with the lander module, and this lander module will communicate with Indian Deep Space Network. Such things are important for prelims examination. So IDSN, where is this located? It is located in Karnataka. Indian Deep Space Network, it is located in Karnataka. Not only that, this lander module communicates with rover module, and this lander module is going to communicate with orbiter of Chandrayaan 2. Orbiter of Chandrayaan 2. And this propulsion module communicates with IDSN, Indian Deep Space Network. So this is alone, isn't it? Yes. So what are the points that we need to understand, okay, from this class? IDSN, where it is located? Karnataka. This propulsion module is alone here. What we are actually collaborating with, what we are actually communicating with? Chandrayaan 2 orbiter. Now, so just okay, from the starting onwards, completed a winner. From the starting onwards, this is the rocket, these are the stages, this is the sequence. Okay. Now, so finally, the spacecraft enters into the orbit of the Earth. It slowly, we are doing the maneuvering slowly, the size of the orbit is increasing, and ultimately at one point of time the spacecraft can able to escape from the gravity of the Earth. It escaped and enters into the gravity of the moon. Okay, slowly the size of the orbit is decreasing, and finally it will get into the orbit which is 100 kilometers from the surface of the moon. After that it will do few revolutions around the moon. After that lander got separated, will land on the moon and rover will be released. Where is lander landing here? 70° south latitude. Now so see, what is the lifetime or lifespan of these modules? For propulsion module, the lifetime is 3 to 6 months. Why I have taken this? Because these are the points that we need to focus here. For lander module and rover module, okay, the time span or the lifespan is 1 lunar day. Lifespan is 1 lunar day. This 1 lunar day is equal to 14 earth days. Earth days. Here day means day part of the moon, not the night part of the moon. Here day means, earth day means 24 hours. One day, one complete day I am talking about. So that too, this lander is going to land at the dawn, because lunar nights, okay, listen carefully, listen, lunar nights, so extremely low temperatures are there, extremely low temperatures. Sometimes the temperatures can go below minus 230 degrees Celsius as well. It can go below minus 230 degrees Celsius as well. So at such low temperatures, it is very difficult to operate, okay, instruments. Is this point clear? So we are landing at the dawn of the lunar day. We are landing at the dawn of the lunar day. Is this point clear? So why not a lunar night? Because at night the temperatures will be extremely low and it is very difficult to operate the instruments. Is this point clear? Yes or no? Yes. And also at night, what will happen? Guess, I am just asking you to guess. Yeah, this is obviously the major point here. The extremely low temperatures, very difficult to operate instruments. Okay, so at night obviously there is no sunlight. They carry solar modules for power. So obviously no electricity. Fine, but this is actually the major point. Now, so what is this lunar day? Okay, what is this lunar night? How this lunar day is actually equal to 14 Earth days? So please take down this. I'll discuss that concept. Yes. Okay, see here. So I'll completed I'll discuss lunar day and night. Lunar day and lunar night. See, what is the rotational period of the moon? The moon also rotates about its own axis. Yes or no? What is the rotational period of the moon? It is actually 28 days. And this is also equal to revolution period of the moon. The moon revolves around the earth. Yes or no? Yes. So the rotation period of the moon is equal to revolution period of the moon. Okay, which is equal to approximately equal to 28 days. Now, what is rotation? Rotation is nothing but rotating about its own axis. Yes or no? What is revolution? Revolving around something. Suppose let us assume this is the earth. Clearly visible, not visible. Okay. So there is a chair here. Now I am considering this as the earth. Suppose let us consider this as the earth. Okay. Now what is rotation? Suppose let us take this is north. ఏంటిది ఏదైనా కావచ్చు నార్త్ అనుకుందాం. ఓకేనా, ఇది నార్త్ అనుకుందాం. దిస్ ఈస్ నార్త్, దిస్ ఈస్ వాట్ వెస్ట్, దిస్ ఈస్ వాట్ సౌత్ ఫేసింగ్, దిస్ ఈస్ ఈస్ట్ ఫేసింగ్. సో వాట్ ఈస్ రొటేషన్? నార్త్ టు వెస్ట్ టు సౌత్ అండ్ టువర్డ్స్ ఈస్ట్. ఓకే, అగైన్ కమింగ్ టు నార్త్. Okay, so this is what rotation. Now, so when the rotation period is equal to revolutionary period, suppose see here, okay, now I am facing the north. I am doing rotation and revolution simultaneously. I am doing rotation and revolution simultaneously. Okay, did I face west? West e kada? Yes, and rotation chesna. Okay, and then did I face south? Yes, and then north, east, yes, and then again north. So I have completed one rotation, one revolution. Is this point clear? I have completed one rotation, one revolution. Is this point clear? Now the point that you need to understand here is, if this is the earth, now while I am doing this, earth can only see my face, not my back. Earth can only see my face, not my back. Yes. If this is the earth, okay, I am just doing like this, na. Earth can only see my face. That means earth can only see only one side of the moon. Only one side of the moon is visible to us. మనం చందమామను చూడగానే చెట్టు కింద పేదరాశి పెద్దం కూర్చొని ఉంటుంది, మనకి ఎప్పుడు అదే సీనరీ కనపడుతుంది, అవునా కదా? బికాస్ వీ కెన్ ఓన్లీ సీ వన్ సైడ్ ఆఫ్ ది మూన్. వాట్ ఈస్ ద రీజన్ ఫర్ దాట్? Rotation is equal to revolutionary period here. Is this point clear? Yes. So we are not seeing the other side of the moon. So the other side is also called as far side, and the country which have launched its lander onto that far side or other side is the China. China in its Chang'e 4 mission, okay, mission has launched its lander onto the far side of the moon, onto the far side of the moon, onto the far side of the moon. Okay, Chang'e 4 mission, China's Chang 4 mission. It landed its lander on the far side of the moon. So this is at 45 degrees south latitude. This is at 45 degrees south latitude. Okay, now listen. Okay, see, what is the rotation period of the Earth? 24 hours. 12 hours day, 12 hours night. What is the rotation period of the moon? 28 days. That means 28 Earth days. 28 Earth days. That means 14 Earth days day, 14 Earth days night. Is this point clear? Therefore, 1 lunar day is equal to 1 lunar night is equal to 14 Earth days. Is this point clear? Yes. So this is about the lunar day and night concept. 45 degrees south latitude. One important point that I చెప్పాను, అపోలో ప్రోగ్రామ్ అని చెప్పాను. 1969 to 1972 మధ్యలో we send NASA send humans to the space under its Apollo program. Under its Apollo program. Now it is doing Artemis program to ultimately send humans onto the moon. Is this point clear? Yes. Okay, come here. Now, what are the modifications they have done after this Chandrayaan 2 partial failure or partial success? So, under this Chandrayaan 3, what are the modifications? What are the features, extra features they have done? Okay, so not that much into technicality, just we'll explain the concepts, okay, which is relevant to us. Now, see, we had propulsion module, we have lander module, and we have rover module. So this lander module now this lander module is provided with more fuel. That means, suppose if the lander, listen, so earlier in Chandrayaan 2, what I have told you, the lander is close to the surface, but instead of decreasing the velocity got increased. Why increased? Because it need to reach here. This is the landing spot. So keeping that on the view, okay, we have provided more fuel to the lander. Okay, fine. Now in Chandrayaan 2 mission, okay, so the landing area, this is in Chandrayaan 2, the landing area is very narrow. It is 500 meter into 500 meter area only. But in this Chandrayaan 3 mission, we have expanded the landing area, so which is 4 kilometer into 2.4 kilometer. Okay, so anywhere the lander can land. Is this point clear? Yes. So therefore it has to travel a more distance. We have provided more fuel. Now see, just try to understand, I can't give that much technicality here. When the landing spot is very narrow, definitely the errors may occur more. Yes or no? Yes. So that's why we have expanded the landing area and we have provided more fuel here. One important point here is, okay, in Chandrayaan 2 mission, when the lander is descending towards the surface of the moon, it will click the pictures of the moon and then it will identify where I need to land. It will click the pictures of the moon and then it will identify where I need to land. Is this point clear? Yes. But such a thing we have avoided here. Instead of lander clicking the pictures to identify the landing spot, listen carefully, instead of lander clicking the pictures to identify the landing spot, already we have orbiter of Chandrayaan 2, it has taken some good pictures and we have fed those pictures into the lander. The only work the lander has to do with respect to landing is, it has to click pictures and to make confirm that this is my landing site. Is this point clear? Yes. Sir, what is the problem with this? What is the problem here? See, I told you it became unstable and it need to take very fast turns and it has to take the photos of the landing spot. So obviously there is a very great chance of becoming unstable. Yes or no? Antena kada andi? You understand this? Yes. Okay. So pictures from orbiter of Chandrayaan 2. Chandrayaan 2 fed into lander module, okay, to identify landing spot. Okay, so these are some modifications they have done in the Chandrayaan 3. So this is about Chandrayaan 3 mission. So I think August 23 we are expecting a landing. I think August 23 we are expecting a landing. We calls unte cheptanandi points. More fuel, we have fed more fuel into the lander module. The landing area has been increased and now it is 4 km into 2.4 km. Yes, 4 km into 2.4 km. Earlier it is 500 meter into 500 meter area. Now just write down this point. Instead of lander of Chandrayaan 3 to click pictures of the surface of the moon, instead of lander of Chandrayaan 3 to click pictures of the surface of the moon, in order to identify the landing spot, okay, in order to identify the landing spot, the pictures already taken by the orbiter of Chandrayaan 2, just write C2 and raskondi enduku maatakante pedda pedda words rastar. Okay, the pictures already taken by the orbiter of Chandrayaan 2 is fed into the lander module, to identify landing spot. So that means when the landing spot is very narrow, when already errors has occurred and during its descent phase it is taking pictures, okay, to identify the landing spot, everything seems to be very tense, na? Yes or no? This is what actually happened in Chandrayaan 2. So they increased the landing area, okay, so they have fed the pictures from Chandrayaan 2 orbiter and they have provided more fuel. Okay, so this is about the Chandrayaan 3. So this is all about the Chandrayaan 3 mission. So I think I have given the total information of this. Okay. Next question. All the previous missions of, you can write down as a question. Okay. All the previous missions before Chandrayaan 2 and 3, landed their landers near equatorial region of the moon. Landed their landers near the equatorial region of the moon. A few latitude degrees north and south of the equator. Why equatorial region is favorable? You can just mention, okay, why equatorial region is favorable. Okay, so regarding that question, okay, let us see why equatorial region is favorable. Equatorial region of the moon, by the way. So the question itself, there is a statement, all the previous missions before Chandrayaan 2 and 3 have put their landers near the equatorial region, few latitude degrees north and south of the equator. Is this point clear? Yes. Now the farthest a lander went from the equator is 40 degrees south latitude. 40 degree south latitude. Okay, and the name of this mission is this one, Surveyor 7. This was launched by NASA in the 1968. So this is the farthest a lander or the spacecraft, okay, has been from the equator. from the equator. And I already told you one point, that is, what is that point? Even China's Chang'e 4, okay, put its lander at where? Yes, 45 degrees south latitude, but this is far side. That means, okay, beyond this, okay, no spacecraft has been landed. Is this point clear? Yeah. But in Chandrayaan 2 and Chandrayaan 3, we are aiming for what? 70 degrees south latitude. That is far away from the equator. That is near the poles. That means the earlier missions, okay, they preferred equatorial regions. Okay, they preferred equatorial regions, and there are some good reasons for that. And ISRO is preferring south poles, okay, polar regions, and there is also very good reason for that. Okay, so we will discuss both. Now, completed? Now, so let us compare the equatorial regions and polar regions of the moon. Region and polar region of the moon. See, in equatorial regions, okay, so the surface is almost even. The surface is almost even. There are only few hills. There are only few craters. Okay, very steep slopes, almost opposite. See, why I am telling this topic? If there is a question, we need to write all this. Okay, na? Very steep slopes, almost opposite. Okay. Anyways, very steep slopes, almost opposite, and sunlight is abundant. Sunlight is abundant and temperature is conducive. Or we can say temperature is favorable. Temperature is conducive. Okay. See, these 2 points are very important here. These two. So, sunlight is abundant and temperature is conducive. That means temperature is not that much very low. What I told you, when the temperature is very low, it is very difficult to operate the instruments, and in order to operate the instruments, as we had solar panels for them, we should require some good amount of sunlight. Is this point clear? Yes, and that is available here. Now, so let us see the polar region. Okay. Now, see, there are few areas, or we can say very less sunlight. Okay. Very less sunlight, and that too, there are few areas where sunlight never reaches. That means they remain in dark for millions of years. Is this point clear? Yes. So, in polar regions of the moon, there are some areas are there where sunlight never reaches. They remain in dark for millions of years. Right. And also extremely low temperatures. So, obviously, because of this reason, so most of the missions, okay, have preferred this in order to study moon. They have preferred the equatorial regions rather than the polar regions. Okay, na? Next question, why ISRO is aiming for lunar south pole? You understand the answer here? Yes. What are the two major points here? Abundance of sunlight and temperature is conducive. Next, okay, why ISRO is aiming for lunar south pole? Why ISRO is aiming for lunar south pole? This is what we are going to discuss. See, I just told you, in the polar regions, okay, so very less amount of sunlight is there, and also extremely low temperatures. Okay, suppose why there is very less amount of sunlight, or why there are few areas where the sun never reaches. This is because of the geometry of the moon. Suppose if you take earth here, suppose if this is earth, I have already told you. Okay, so this is the axis of earth rotation, yes or no? Yes. So what is this angle? Yes, it is 23.5 degree. Suppose here is the sun. Okay, suppose here is the sun, here is the sun. Okay, now this is what? This is the north pole, and north pole is receiving the sunlight, good amount of sunlight. Yes. Now this earth rotating about its own axis and it is revolving around the sun. Now here is the sun. Ardhamainda nenu cheppindi? Now this south pole is receiving good amount of sunlight, yes or no? Yes. But if you take the case of the moon here, this is the moon, okay, and so this is the axis of the moon. This is the axis of the moon. This is the axis of rotation, and this angle is only approximately equal to 1.5 degrees only. 1.5 degrees only. Is this point clear? Yes. So this is the first point. Okay, this is because of geometry of the moon. The second point here is, okay, the second point here is, so I told you there are craters present, okay, on the surface of the moon. There are few areas inside of those craters, they remained in dark for millions of years, or we can say sunlight never reaches those areas, okay, for millions of years, okay, for millions of years. Okay, that is one point. And the third point here is extremely low temperatures. Extremely low temperatures. Now listen. So extremely low temperatures are there. There are few areas where sunlight never reaches. There may be a chance that some clues, okay, may get frozen in time for millions of years without any change. Extremely low temperatures, okay, some areas there is never sunlight, there may be some clues frozen in time for millions of years without any change. This clue can be an organic material, or can be a soil, can be a rock. It got frozen in time and it doesn't change, okay, over the period of time. Is this point clear? So by exploring such things, we can understand the early phase of the solar system. So that is why, okay, ISRO is aiming for the lunar south pole. Is this point clear? In fact, the Chandrayaan 1 mission, what are its findings? Water and it found H2O and OH. That is one point. Second point is their abundance, okay, their presence increases towards the polar regions. That's why we are aiming for the polar region. Is this point clear? Yes. So that is about this. Now why only south pole? Actually there is no much big difference between south pole and north pole, okay, but earlier missions went towards the south pole only. That's why we are also going to the south pole. But south pole has a slight advantage when compared to north pole with respect to abundance of sunlight. Is this point clear? Yes. But there is no much difference. In future also there will be missions towards the north pole. So the polar regions are important. So how polar regions of moon are important? There are few areas in the craters where sunlight never reaches, and due to extremely low temperatures, there may be some hidden clues which are frozen in time without much change. Okay, we are exploring that. Okay, so this is about the this question, why ISRO is aiming for the lunar south pole. So why moon has such advantage? Because of its rotational axis, okay, because of its geometry. Yes. So when compared to the side which we are seeing, the other side has less amount of sunlight. Okay, the side which we are seeing the moon, it has good amount of sunlight actually when compared to other side. So the so objective questions, what are the answers? Chang 4 mission China, 1 lunar day, lunar night is equal to 14 earth days. Yes. Okay, still there is some time. I like to give you some objective questions. Okay. Nowadays we are expecting some good questions in physics also. Okay. Let's talk about something, gravity. Gravity. Okay. There was one question, very good question, very good question. It's a previous year question. How many fundamental forces are there in nature? There are actually 4 fundamental forces are in nature. 4 fundamental forces are there in nature, and one of them is gravitational force. And this gravitational force is a weak force or a strong force? Is this gravitational force is a weak force or a strong force? So gravity is one of the 4 fundamental forces, okay, and this gravitational force is a weak force. Weak force. I'll tell you. So according to Newton's laws of universal gravitation, Newton's laws of universal gravitation or universal gravitational law simply, okay. So what he said is, any 2 objects having mass, listen, any 2 objects having mass, there is a force of attraction present between these 2. So what is the meaning of that? Okay. Suppose, so these are the 2 objects, okay, any 2 objects placed when they are separated with some distance having masses, okay, there is a force of attraction present between these 2. Okay, that means there is a force of attraction present between these 2, and that force of attraction is called gravitational force. What is the meaning of this? That means between these 2 objects there is a gravitational force. Okay, so between me and that laptop there is a gravitational force. Between me and the moon there is a gravitational force, that is a force of attraction, because we had masses. Okay, when there is a force of attraction, why can't these 2 objects collide? Why can't these 2 objects come closer to? Because there is a force of attraction now. What is the reason? Gravitational force is a weak force. Okay, but if you calculate that force, okay, G into m1 m2 divided by r square, so if you put the value of G, it is something like 10 power minus. Okay, so if you calculate, if you put the masses of these 2 objects and calculate the gravitational force, it comes to very less value, and that less value force of attraction present between these 2 objects can't even overcome the friction present between this object and my hand. Is this point clear? Ardhamainda andi? Yes. So gravitational force, one of the 4 fundamental forces, it is a weak force. Why it is a weak force? I told you the reason here. It cannot overcome the force of attraction present, the friction present between the object and the surface. But gravitational force is very essential. It provides the necessary centripetal force so that objects revolve around the another object in this space. Fine. So that is about the gravitational force. Okay. So let's talk about gravity. Okay. So the question here is gravity same throughout the Earth's surface? Is gravity same throughout the Earth's surface? No. Okay. So what is gravity basically? Suppose if this is the Earth, okay, and suppose let us take this is the object. When I release the object, okay, comes closer to the Earth and fall on the Earth. Why? Gravitational force. That means there is a force of attraction present between this Earth and this object. Is this point clear? Yes. See, one thing here is, what is this gravitational force? Suppose let us take F is the gravitational force, and this object put this F gravitational force on the Earth and tries to attract the Earth towards it, and this Earth put this F gravitational force on this object and try to attract the object towards it. Is this point clear? అర్థమైందని చెప్పింది. ఈ ఆబ్జెక్ట్ అర్త్ మీద ఎంతైతే గ్రావిటేషన్ ఫోర్స్ పెడుతుందో అంతే గ్రావిటేషన్ ఫోర్సు ఈ అర్త్ ఈ ఆబ్జెక్ట్ మీద పెట్టి లాక్కోవడానికి ప్రయత్నిస్తుంది. కానీ మనం ఈ ఆబ్జెక్ట్ అర్త్ వైపు మూవ్ అవుతున్నట్టు చూస్తున్నాం, కానీ అర్త్ ఆబ్జెక్ట్ వైపు మూవ్ అవుతలేదు. ఎందుకు? రీజన్ ఏంటి? బికాస్ న్యూటన్ సెకండ్ లా F ఈజ్ ఈక్వల్ టు ma. ఓకే, సో ఇఫ్ ఇట్ ఈస్ ది మాస్ ఆఫ్ ద అర్త్, ఓకే, what will be the acceleration? Suppose let us take F equal to 10, just మీకు random thing. Okay, so ఎంత అవుతుంది ఇప్పుడు చెప్పండి. సపోజ్ ఇది let us take 10,000 అనుకోండి. ఓకే, ఎంత అవుతుంది? A equal to 10/10,000. ఓకేనా? దిస్ ఈజ్ ద కేస్ ఆఫ్ ద అర్త్. ఓకే, సపోజ్ ఇన్ ద కేస్ ఆఫ్ ది ఆబ్జెక్ట్, ఓకే, సో F equal to 10 అన్నానా, ఆబ్జెక్ట్ యొక్క మాస్ ఎంత? 1 తీసుకుందాం. A equal to ఎంత? 10. అంటే in which case the acceleration is more? The acceleration is definitely more for this object, yes or no? దిస్ ఈజ్ ద యాక్సలరేషన్ ఫర్ వాట్? సి నేనేం చెప్పినాను, సపోజ్ ఎఫ్ ఈక్వల్ టు 10 తీసుకుంటే 10 న్యూటన్స్, ఓకే, ద యూనిట్స్ ఆఫ్ ది ఫోర్స్ ఇస్ న్యూటన్స్, ఓకే. Now the earth will put a 10 Newton of force on this object and try to attract this object towards it, and this object also put 10 Newton of force on this earth and try to attract the earth towards it. Is this point clear? Yes. Now let us come to Newton's second law, F equal to ma. In both cases the force is same, but the masses are different. Let us take the mass of the earth is 10,000. I am just taking a rough example, and the mass of the object is 1. So what will be the acceleration of the object? 10. What will be the acceleration of the earth? This is very, very low number. So that's why the object is moving towards the earth, but the earth is not. We are not seeing the earth is moving towards the object, because the acceleration experienced by the earth is very, 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 very less. Is this point clear? Yes. But one thing is very clear here. Okay, entaithe earth force ee object meeda pedutundo ante force ee object earth meeda kuda pedutundi. Is this point clear? Yes. Because that is universal law of gravitation. That's what Newton said. Fine. ఓకే, నౌ దట్ ఈస్ వన్ పాయింట్. ఓకే, జస్ట్ నేను ఇక్కడ మనం సెలెస్టియల్ బాడీస్ గురించి మాట్లాడుకుంటున్నాం కాబట్టి ఈ టాపిక్స్ చెప్తున్నా. నౌ లెట్ us కమ్ టు ద సర్ఫేస్ ఆఫ్ ది అర్త్. ఈ సర్ఫేస్ ఆఫ్ ది అర్త్ మీద ఓకే గ్రావిటీ ఒకేలాగా ఉంటుందా? ఉండదు. సో గ్రావిటీ అంటే ఏంటి? సో గ్రావిటీ ఈజ్ యాక్చువల్లీ ద యాక్సలరేషన్ ఎక్స్పీరియన్స్డ్ బై ద ఆబ్జెక్ట్ హియర్. యూ కెన్ అండర్స్టాండ్ ఇట్ యాజ్ ఎ గ్రావిటేషనల్ ఫోర్స్. ఓకేనా? సో గ్రావిటేషనల్ ఫోర్స్ అంటే ఈ సపోజ్ అర్త్ ఒక ఆబ్జెక్ట్ మీద గ్రావిటేషనల్ ఫోర్స్ పెట్టి తన వైపు లాక్కుంటుంది అంటే తన సెంటర్ వైపు లాక్కుంటుంది అని అర్థం. అవునా? సపోజ్ see this is actually spherical shape, but the earth shape is not spherical. It is actually yes, it is actually geoid in shape. It is like this. Okay, that means so the distance from the pole to the center is less when compared to the distance from the equator to the center. Is this point clear, everybody? Yes. Now tell me where the gravity is obviously more? Polar regions, because it is very close to the center. So here the gravity will be less because it is very far from the center. So equatorial regions gravity is minimum. I am using the word minimum. Okay, polar regions the gravity is maximum. Okay, suppose if we are going inside of the earth, ఇలా హోల్ డిగ్ చేసుకుంటూ వెళ్ళాం అనుకోండి, గ్రావిటీ ఏమవుతుంది? యాక్చువల్లీ తగ్గుతుంది. లేదంటే నేను ఇప్పుడు ఫార్ములా చెప్పాలి, అంత అవసరం లేదు, జస్ట్ గుర్తుపెట్టుకోండి, తగ్గుతుంది. వెన్ వీ ఎంటర్డ్ టు ద సెంటర్ ఆఫ్ ద అర్త్ ద గ్రావిటీ బికమ్స్ జీరో. ఓకే, సిమిలర్లీ ఆన్ ద మూన్ ద గ్రావిటీ ఈజ్ లెస్ వెన్ కంపేర్డ్ టు ద ఆన్ ద సర్ఫేస్ ఆఫ్ ది అర్త్. ఓకేనా? సో దీస్ ఆర్ సమ్ ఇంపార్టెంట్ పాయింట్స్. ఓకే, ఐ విల్ కంక్లూడ్ హియర్. సో ఇన్ టుడేస్ కరెంట్ అఫైర్స్ క్లాస్ we have discussed everything about the moon and Chandrayaan missions. Okay, so the points are gravity is maximum at the poles, minimum at the equator. Inside the mine gravity is less. When we go to the center of the earth gravity is zero. ఎందుకంటే మనం లోపలికి వెళ్ళే కొద్దీ సపోజ్ ఇలా వెళ్తున్నాను అనుకోండి, ఇప్పుడు ఇక్కడ ఉన్నాను అనుకోండి నేను సర్ఫేస్ ఆఫ్ ద అర్త్ మీద, దిస్ ఈజ్ ద టోటల్ మాస్ ఆఫ్ ద అర్త్ దట్ ఐ నీడ్ టు కన్సిడర్. అదే నేను ఇక్కడికి వెళ్ళాను అనుకోండి, దిస్ ఈజ్ ద టోటల్ మాస్ ఆఫ్ ద అర్త్ దట్ ఐ నీడ్ టు కన్సిడర్. అవునా కదా? సో అంటే ఇక్కడ మాస్ కూడా తగ్గుతుంది కాబట్టి, సో అంటే ఇప్పుడు డెన్సిటీ ఈక్వల్ టు మాస్ బై వాల్యూమ్ అనే ఫార్ములా ఉంది కదా, సో డెన్సిటీ కాన్స్టెంట్గా ఉంటుంది. ఓకే, మాస్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు వాల్యూమ్. సో వాల్యూమ్ అనేది క్యూబ్లో ఉంటుంది కాబట్టి, ఓకే, సో వాల్యూమ్ తగ్గుతుంది కాబట్టి మాస్ కూడా తగ్గుతుంది అనమాట, అది క్యూబ్లో తగ్గుతుంది. ఓకే, ఎనీవేస్ యూ కెన్ రిమెంబర్ దిస్ పాయింట్. ఓకే, ఎనీ డౌట్స్? సెషన్ క్లియర్?